For Scoff, and today I'll be speaking about system hardening, specifically using Ansible to harden cloud servers. To go over the outline, we'll be talking today about my project scope, the project benefits, the network diagram, a brief STIG overview, a look at the project schedule, and then we're going to go into a live brief demo. Getting right into the project scope. The purpose of this project is to utilize Ansible alongside DigitalOcean to fully create and provision a minimum of 2 droplets with LAMP stacks, and then enable STIGs to harden and increase security on the servers created. The 2 droplets will have 1 GB of memory and 20 GB of hard drive space. The project will be completed by June 27th, 2021. And by using Ansible to deploy 20 STIGs, we can effectively automate hardening cloud systems and massively improve cybersecurity. After every STIG is enabled, extensive testing and validation will take place to ensure that the system is properly secure. Going into project benefits, first off with reliability, DigitalOcean offers 99.99% uptime, with offline time being refunded back to your account. That means on the rare occasion that DigitalOcean crashes or the servers go down, you will not be charged for it. By using DigitalOcean, the client can offer reliable servers with high access to their clients or workers. Next up is scalability. By properly using Ansible alongside DigitalOcean, the client will be able to scale their operation down or up based on what the client needs. And cost reduction. By utilizing DigitalOcean, the client will not have to spend large amounts of money on expensive hardware such as servers, as well as pay for their upkeep. And security. By focusing on using Ansible to create hard and secure servers, there is little to no chance of having the client have important information leaked. Going into the network diagram, this is a brief overview. If you look on the left, you can see that the Ansible script is sent from the CentOS 7 Ansible controller to DigitalOcean, where it provisions the 2 droplets. More droplets can be provisioned if needed, and then you can SSH into those droplets. And then on the right, there is a more detailed network diagram of exactly what the process is that's happening. So the user logs in, and then it sends an access application to the private cloud, and then it checks for the token authorization from the user, and then it sends a token request back to the security token provider, and then the IAM provider gets the SMAL token, and the token authorization happens, and then the user gets access with the token. Now here's an overview of all the 20 STIGs that I used for this project. Obviously I'm not going to read them out loud all right now, but I tried to focus mainly on user settings, such as passwords, making sure users that were just created need more security, they can't use certain commands, and that's what I focused on for the STIGs for the main part. Now for the project schedule, if you look on the screen, you can see we have the 4 main milestones for research, configuration, penetration testing, and project finalization. Each one of those milestones has several steps underneath it, and at this point they are all completed, and that is why they are highlighted green on the right. This project took a total of a month. Each milestone lasted a week, and now we are at the finish line. Now, time for our brief live demo. So you can see I have DigitalOcean opened up in this webpage. I'll refresh it so you can see I don't have any droplets. I don't have any droplets. Alright, now we're going to go into our host, and we're going to run our playbook. I'll try to give a brief walkthrough of what's happening. So right now it's making sure the SSH key is present, and then it's creating the SSH key if it's not present. Now it's creating the new droplets. If we look over here, we might see they should pop up pretty soon. Yep, there they are. So now those are being created. And you can see they're literally in the process of it. Yep, there goes that bar. with Create It. Okay, so now it's adding the host to the inventory. And it's pausing for about 30 seconds. Because otherwise, if you run it too fast, it can overlap and cause issues. Okay, now we're installing Apple Release. This is for the LAMP stack, specifically so we can update PHP and the REMI repository. And now it's enabling the REMI repository. And now we're installing the PHP LAMP stack. Now, once we get to the part where it starts downloading the stigs, I'll try to go into a little bit more detail about which stigs I selected and why. Okay, it's starting Apache. It's enabling MariaDB and creating a MySQL user. Creating a WordPress database. I believe I didn't take that out of the script from last month, but it can still be used. Now we're getting into all the stigs. Use Red Hat official rel stig. And yep, all those are activating. All right, let's go back here. So as I said already, and you can probably see from looking, I focused on passwords. So if we look, passwords must be a minimum of 15 characters in length. Obviously that seems like a little bit of overkill, but if you're working in government or somewhere that's high security, that's extremely important so your passwords don't get cracked. When passwords are changed or new passwords are established, the new password must contain at least one uppercase character. That, I believe, is a minimum. It's usually better if they contain more than one uppercase character, but that works. And when passwords are changed, a minimum of 8 of the total characters must be changed. You can't use the same similar passwords, especially if one of yours was already found out. And when passwords are changed, the number of repeating characters of the same character class must not be more than 4 characters. Same as the last one. When passwords are changed, the new password must contain at least one lowercase character. Same thing with the uppercase character. And when passwords are changed, a minimum of 4 character classes must be changed. When passwords are changed or new passwords are assigned, the new password must contain at least one special character. That's pretty important. And passwords must be prohibited from use for a minimum of 5 generations. It's important, especially if one of your passwords was cracked already. You don't want to go back to reuse that password after you forget about it. Passwords for new users must be restricted to a 24-hour, 1-day minimum lifetime. So if a new user comes to your work and you make them a password, their password has to be restricted to last at least 24 hours before it expires. And passwords for new users must be restricted to a 60-day maximum lifetime. So a new user has to set their own password before 60 days, which is pretty generous. The operating system must disable account identifiers, individuals, groups, roles, and devices if the password expires. And the system must not have accounts configured with blank or null passwords. That would be horrible. So those are the majority of the password ones. Let's see how the script is doing. And it is complete, so we can look through everything that happened real quick. And we can see all the stigs that I just went through have been properly uploaded. Over here. And there is our secured servers ready to SSH into. Anyway, once again, my name was Forrest Goff, and this was my presentation on system hardening.